Hello and welcome. My name is Itai Schuftan, and today I'd like to show you the project Aviv Galon and I worked on in the course of Advanced Software Development by Dr. Khalasschi. This project is about creating a friendly user interface which will help us to control an aircraft in the Flight Gear Simulator app. During this course, we went over 5 major milestones. First milestone was about the server-side architecture and design principles such as grasp and solid. The second milestone was about files and socket streaming, including building a file cache manager in the server. The third milestone was about understanding the pseudocode and implementing it into our server to help us solve the shortest path problem. The fourth milestone was about building a custom language interpreter, which takes a kind of a made-up language and translates into a command that will be able to control the aircraft in the Flight Gear Simulator app. The fifth and the last milestone was about creating a desktop app using JavaFX, which in this case is our GUI for the flight simulator. So without further ado, let's launch the app. First, we're going to start by launching our server and then the client. The server here, which is now running, is our server that's controlling the problem solving of the shortest path. So let's see what we have here. First, we can load the map, and this map is basically a representation of the topographical view where the plane is. We can see the plane here on the top left corner, and now we'd like to know what's the shortest path from this point to any other point in the map. So in order to do so, we will be connecting to our server who can handle these types of problems and just select any point in the map. So for example, this one, this would be the easiest path to get to. So this one. Now notice that once we press on a specific area, a file is being made with the solution for it. So later on, it will be easier for the system to get the solution and not recalculate the whole thing from the top. Now, let's load the autopilot script and see our plane taking off automatically. Now, I want to mention that this software, the Flight Gear software, is a heavy piece of software, so it's going to take it a while for it to load. So let's wait. While it's loading, you can see that here in the autopilot script, we have our made-up language, and we have an interpreter that will be able to take this text and translate it into actual code that this simulator will be able to work with. Okay, so our flight gear is now up and running, and in a few seconds we will be able to see the throttle, which is right here, getting pushed all the way to the end, and the plane will start taking off. I'm not going to touch anything now. As you can see, the throttle is now inserted all the way through. Our plane is starting to move forward and then to the side. It doesn't really like the runway, but it still will be able to take off. And once it will hit 500 feet, we will be able to move to manual mode. You can actually do it anytime, but we just want to see the script runs all the way to the end. And actually, we can see that the simulator is sending back the data about the plane current height. So we just got a blackout for a second there, but the plane is still fine. We are currently 350, I guess, feet below sea level. So again, once we get to 500 feet, we will go into our manual mode and control the plane ourselves. In the meantime, since the simulator is also already up and running, we will connect to its port right here. And now, in the system log, as you can see, we are being connected to the simulator itself. So let's see, the script is running all the way to 500 feet, and then we'll control the plane ourselves. Okay, nice. So you can see that the script finished running. It did print done. Now let's move into manual mode. As you can see in the system logs, we got switched to manual mode. I'm going to put the throttle all the way through, and we can move the rudder to both sides, controlling the plane, and also use the joystick itself to make the plane move accordingly to the joystick position. This is very cool. I like it. Okay, enough of that. Let's close everything and go back. So now let's talk a little bit about the design patterns of this project, starting with the server side. As you can see, we've separated the server responsibilities for each type of action. We have the server interface, which sole purpose is to handle connections and sockets, whereas the client handler purpose is to attend to the client's requests, which is in this case is all about getting the shortest path. You can also see that we've added a file cache manager, which has the purpose of saving past path in the memory of the server for a quicker response time. In order for the server to be able to solve the shortest path problem, we've used the bridge design pattern. By using this design pattern, we've ensured that it will be much easier to add more types of algorithms and even more types of problems as long as they are of type searchable. In this case, you can see that we've converted our matrix as our map into something that our solver can work with and run a searcher on. For the client side, we've used fxml, so our map drawer is basically extending the canvas, adding more properties to it, such as the map matrix and the points on the map. Our redraw method redraws the map whenever there's an update, and our draw path method also updates when the new path is being calculated. We also have the joystick controller, which its events and the main window controller initializes the project with these two data members, including their methods. For this project, we use the MVVM design pattern, which stands for Model View View Model. When the app starts, it's binding the data between the view and the view model. Once this is set up, each time the view sends an event, such as moving the joystick, the view model converts these events into something the model will be able to understand and work with our consumer, which is the flight simulator. The view model is observing the model, and this is how it gets notified from our flight simulator about its current state and how the view affected it, like its current height. Thanks for watching. I was Itai Schuftan, working on this project with Aviv Galon, and see you next time.